You just bought a mobile proxy and the provider handed you one cryptic line, a host, a port, a username and a password, and no idea what to do with them. By the end of this video, that line will be a working request returning a real Singapore carrier IP, and you will know how to prove it is working with your own eyes. And isn't that why I reviewed you may see dual SIM cards from Singtel, M1 and StarHub. So I set up these exact connections every day, and almost every problem people hit is one of about 5 small things. I will show you the working path first, then the 5 things that break it, then a real work example narrated end to end. We are going to do this in 2 tools. First, cURL, because if cURL works, then your credentials and your network are fine and you can stop guessing. Then Python requests, because that is where most people actually run their code once the proof of concept is done. Start with what you have. 4 pieces, a host, which is the gateway you connect to, a port, which is one number that maps to one phone on my farm, a username and a password. Write them down because every command from here uses those same 4 values in the same order. A quick word on what that port actually is, because it explains a lot of behavior later. On my farm, each port is wired to exactly one physical phone. So when you connect to that port, you are not getting some abstract slice of a pool, you are borrowing one real device on one real tower. That is why a mobile proxy feels slower than a data center line. And it is also why the IP looks like a normal Singapore consumer to the sites you visit. Here is the one cURL line that proves everything. cURL -x, then http://user:/pass at host:/port, and point it at an IP echo endpoint like api.ipfi.org. The -x flag sets the proxy. That is the whole trick, and it is the same flag whether you are doing HTTP or SOCKS 5. Let me slow down on that proxy URL, because the order trips people up. It is the scheme, then username:password, then the @sign, then host:/port. If your password has odd characters in it like an @sign or a slash, you have to URL encode them. Otherwise, cURL reads the @sign in your password as the start of the host, and the whole thing falls apart. When that command returns, look at the IP it prints. That number is not your IP. It is the IP of one of my phones in Singapore, the carrier IP your traffic is now wearing. If you see a Singtel or M1 or StarHub address there, you are done. The proxy works and your creds are good. Now add one more flag to that first probe. --max time 10. Without it, if you fat finger the port by 1 digit, cURL points at a phone that is not yours or at nothing at all, and it just sits there until some long default timeout. With max time 10, you fail fast in 10 seconds instead of staring at a frozen terminal, wondering what went wrong. 2 more cURL flags worth knowing early. -s makes it quiet so you only see the body, which is nice when you are scripting. And -v makes it loud, printing every connect and every header, which is what you want the moment something misbehaves. I keep -v in my back pocket for every weird case. Now the SOCKS 5 version, because it matters more than people think. Same command, but swap the scheme to SOCKS 5h. cURL -x SOCKS 5h //user:/pass at host:/port. Notice the letter H on the end of SOCKS 5h. That one letter is the difference between safe and leaking. Here is why. Plain SOCKS 5 resolves DNS on your own machine. So even though your traffic exits through my Singapore phone, your computer is still asking your real ISP to look up the domain. That is a DNS leak, and it quietly tells the world where you really are, even while your IP looks Singaporean. SOCKS 5h sends the hostname through the tunnel, so the proxy does the lookup on my side. Always use SOCKS 5h. So that is cURL. 1 line, 2 schemes, 2 safety flags, and a way to confirm the carrier IP with your own eyes. Now let us move the exact same idea into Python. In Python requests, the proxy lives in a dictionary with 2 keys, HTTP and HTTPS. You set both keys to the same proxy URL, the same http://user:/pass at host:/port you used in cURL. Then you pass that dictionary into your get call as the proxy's argument. And here is the check that matters. Point that request at the same IP echo endpoint and print r.json. If the IP in that JSON is the carrier IP and not your home IP, your Python is wired correctly. Do not skip this step. Verifying the exit IP once at the start saves you from a whole scrape that quietly ran on your own address and got you nowhere. The HTTPS key trips up more people than anything else. If you only set the HTTP key and forget the HTTPS one, then your plain HTTP requests go through the proxy, but your HTTPS requests go straight out on your real IP, and almost everything is HTTPS now. Set both keys every time, even when they point at the exact same URL. I have lost count of how many leaked scrapes trace back to a missing HTTPS key. For SOX 5 in Python, you need one extra thing. Request does not speak SOX out of the box. You install request with the SOX extra, the request bracket SOX bracket version with pip, and then you can use a SOX 5H URL in the very same proxies dictionary. Same two keys, same shape, just the SOX 5H scheme instead of HTTP. If you forget the extra, you get a clear error about a missing dependency. So at least that one tells you what is wrong. Now sticky sessions, which is why you want a session object. When you create a request session and put the proxies on it, every call through that session reuses the connection and stays on the same phone. That is what you want for anything that logs in, because a login that jumps to a new IP halfway through looks like fraud to the target site and gets your account flagged. A session helps you in a second way too. It keeps the connection to the proxy warm. The first request through a fresh connection pays the full cost of opening the tunnel and doing the TLS handshake, and on a mobile line that can be a few hundred milliseconds. Reuse the session and every request after the first one is much quicker because you are not rebuilding that tunnel each time. Sopano, dia terminal, dia tahu, webis terbatas all one. A real phone on a real tower has higher latency than a data center box, and the radio can blink for a moment during a handoff between cells. So set your read timeout generously, 15 to 30 seconds, not the 3 you might use on a wired connection. A lot of so-called proxy failures are just a client that gave up a quarter of a second before the carrier was about to answer. Let me give you the 5 things that break this, because you will hit at least one. Number 1, a 407. That means the proxy got your request but refused your credentials. Either the username or password is wrong, or your own IP is not on the allow list for that account. Let me stay on the 407 for a second, because it is the most common message in my inbox. First, copy the username and password straight from your dashboard with no trailing space, because a stray space at the end is enough to fail. Second, check your auth mode. Some accounts use username and password, others use IP allow listing, and if you are on allow list mode but sending a username and password, or the other way around, you get a 407. Third, if you are on allow list mode and your home IP changed, you are no longer recognized, so add your current IP and it clears. Number 2 on the list, you forgot the HTTPS key, so your real IP leaks on HTTPS. Number 3, you use SOX 5 instead of SOX 5H, so your DNS leaks even though your IP looks right. Both of those we already covered, but they belong on the list because they fail silently. Nothing errors out. The request succeeds, it just succeeds on the wrong identity. Number 4 is environment variables, and this one is sneaky. If you ever set HTTP_proxy or HTTP_proxy in your shell, Python and cURL may quietly pick them up and root through them, ignoring what you wrote in your code or fighting it. So when something behaves strangely and you swear your code is right, check your environment first. Echo those variables and see what is actually set. Clearing a stale one has fixed more mystery bugs than I can count. Number 5 is just forgetting to verify the exit IP at all. People wire everything up, see a 200 OK, and assume it worked. But a 200 only means the request completed, not that it went through the proxy. Always print the IP and read it before you trust the setup. Now let me narrate the real work example, the exact order I do it in every day. Step 1. I run the curl -x HTTP line with max time 10 against the IP echo endpoint, and I read the IP. It comes back as a Singtel address, not my office IP, so the creds and the line are good. Step 2. I run the same line again but with SOCKS 5H, and I confirm two things at once. The IP is still the carrier IP, and because I am on SOCKS 5H, the DNS lookup happened on my farm, not on my own resolver. That is the leak closed before I have written a single line of code. Step 3. I move into Python. I build the proxies dictionary with both HTTP and HTTPS keys pointing at the SOCKS 5H URL. I install the SOCKS extra if it is a fresh environment, and I fire one get at the IP echo endpoint with a 20-second timeout. I print r.json and read the IP one more time. Carrier IP, not mine. Now I trust it. Nasamin ni patient si nakpip. DS4. For anything with a login, I wrap it in a session so the whole flow stays on one phone, and only then do I point it at the real target. That ordering means by the time I touch the actual job, every variable that could leak my identity has already been proven clean. So the finish line is always the same two checks. Confirm the exit IP is the carrier IP, not yours, and confirm DNS is resolving remotely by using SOCKS 5H. When both are true, you are running clean, and everything after that is just your normal code. If you want creds that just work like this, on real Singapore mobile apps with sticky sessions and DNS that routes through the tunnel so you stop leaking your real resolver, grab a trial at singaporemobileproxy.com/client/trial and use the code YT30. These are the same Singtel M1 and StarHub phones I set up on every single day. So the curl line and the Python dictionary from this video work as soon as you paste your host and port in. Subscribe for 2 new videos every weekday.